Right, so we started the discussion about linked list. Let me recall what we covered, and we can continue the remaining part. We have three types of the linked list. Those are single linked list, double linked list, and a circular linked list. In single linked list, we have only single link. By the name, we can understand that singly linked. We have only one link to traverse. Doubly linked list, we have two links, one forward link, one backward link. Circular linked list. So last node link will be connected to the head node, that is first node. First node link will be connected to the last node. So these are the three categories of the linked list. So this is the operations. These are the operations what we can do with help of the single linked list. See now, every node have only one link, one pointer, one arrow. This is arrow. Arrow indicates one pointer. More technically, that is one link. We can observe only one link we have with every node. So this is the starting node. Starting node is called head node. And head node has a pointer to the next node. In the same way, this node contains the pointer to the next node and so on. Okay. And coming to the last node, it has the null node because that is the last node. No any node is available after that. That's why the link of the last node is null. Now, coming to the insertion operation, how to insert a new node. We need to change these links. Okay, this link will be diverted to the new one, and a new node next link will be attached to the next node. We covered this already. Just recalling this. Observe this. So dotted line means we must disconnect that and connect this node address to the new node and the new node next address to the this one. So now in between these two nodes, the new node will be inserted. Delete operation very simple. So if suppose I want to delete this node, target node is nothing but the node which you want to delete. Very simple. So in general, we have the links like this, right? So just disconnect this link and connect this link to the directly next node. So by default, this node will be delinked, disconnected. So this is how to implement a delete operation. Now this is the code. We started the code explanation also in the last session. First, we need to define the node because what you want to maintain in the node, you need to specify. As I said, in every node, we have one data element, one next. Next is nothing but one pointer, one data and one pointer. Data is stored to the elements. Pointer is stored to point the next node. Okay. And next, step two, creating the linked list with help of the node class. Then how to insert a node? Just now we have seen in the graphical representation how to insert a new node. We need to change the two pointers. Okay. So same code we are implementing here. Delete the node. We need to disconnect that particular target node and adjust the pointers of previous node and next node. Display the linked list. What are the list or elements available at the particular point of time? We can use display method in the code to display the elements whatever we have in the linked list. Then search for a value. We need to receive a value from the user at the runtime, and we need to search for that particular key, whether the key is available or not in the given linked list. So for that, until reaching to the last point, how we know that is the last point? Null. If we reach to the null, that is the last point. If the link is not equals to null, we can continue our operation. While temp not equals to null means if the pointer value is not equals to null, nothing but we have next node. So you can continue the operation for searching the data. So key is nothing but the element with which for what we are searching. Temp data means the data whatever you have in the every node. So every node data is going to be compared with the key element. Key element is nothing but the element for which we are going to be searched. If the key is found, we are returning true. And after that, every iteration, we need to increment the pointer temp equals to temp dot next. If the key is not found, we want to return false. Next. So as we implemented insert, delete, display, search methods, we need to call them. As we know that technically, even though if you develop any method, that will not be activated until we call that. So we need to call that from the main method. So for the main method, you can write the main method within the same class, or you can create a new class. I'm creating a new class. Class name is linked list demo. Public static void main string as usual. First thing is we need to create the object for the class. In the previous slides, we used single linked list class. Now. For that, we need to create the object. With help of that object, we need to call the insert method. Just now we discussed insert method. This is the insert method. We need to call this insert method. While calling the insert method, we need to pass one value. Into data, na, we need to pass one integer value. Now see list dot insert passing 10. One value we need to pass, right? Then again I am calling the same method by passing one more value 20. So like that, I am calling the insert method 4 times with 4 different values. Those values are 10, 20, 30, 40. So then what is the use of this method calling? We inserted 4 elements in our linked list. Those are 10, 20, 30, 40. That is the mean. After inserting, just I want to display the linked list. For that, we have written already display method. Okay. So with help of the display method, all the inserted elements will be displayed. Next operation, I want to delete a node. For that, we need to call delete method. We have written the delete method also, no? Delete method. Okay. So we need to call delete method and we need to pass the element, which what is the element you want to delete? We need to pass that particular element. See, I want to delete 20. So object name list dot delete 20. 20 will be deleted. After that, let me call display method once again to cross check whether the 20 is deleted or not. Right? So linked list after deleting 20. Again, I'm calling display method. So it should not display 20 after deleting, right? So we need to cross check that. Next operation is searching operation. So I want to search for the 30. We have written search method also. See, search method name is search. The return type is Boolean. That might be written true or false. If the given element is available in the linked list, that returns true. Otherwise, that returns false. In such a way, we have written the code. And search method receives one value, one integer value. That's why you observe that this is the method calling statement list dot search 30. So I am going to search about the key 30. So obviously we have the 30 in our linked list now. We inserted 30. Okay. So that is going to search whether the element is available or not. If element is available, that returns true. So if we execute the code, we'll get the output like linked list after insertion 10, 20, 30, 40, and null. We are not inserted null. By default, the last element pointer is null. Then we have called the delete method by passing 20 now. So we deleted 20. After deleting, again I want to check. So that's why I called display method once again. So now you can observe there is no element 20, 10, 30 directly. 20 is deleted. Okay. 10, 30, 40 null. And after that, we called search method also for 30, right? Is 30 in the list? True, because we have 30 in the list. So let me execute the code. Then you will get idea. So this is the same code what I discussed with you as of now. Same code I have written here. Observe. Delete method, insert method, search method, display method. And after that, creating one more class to call and inserted 10, 20, 30, 40, display, 20 for the deletion and display, right? So let me execute this. Now see the output. Linked list after insertion 10, 20, 30, 40 null. Linked list after deleting 20, 10, 30, 40 null. No 20. Is 30 in the list? It returns true because we have 30. And let me change the code for better understanding. For example, coming to the delete, I deleted 20 now. After that, let me check for search for 20. So I change the code for the search operation 20 because before that already I deleted 20 now. Let me execute now what will be happen observe. Now see 10, 20, 30, 40. Linked list after deleting 20, 10, 30, 40 null. Is 30 in the list? Now false. Observe here. Previously we are getting true here. But in this case we are getting false because I am searching for 20, not 30. Okay. 20. So is 20 in the list? False. Like that, you can change the code to get more knowledge about this code. Try to modify the code little bit and try to understand the insights of the code and try to change the inserting values, try to change the delete values and search values and so on. Okay. Now, next. So this is all about singly linked list only. As we covered three types of the linked list, we have singly linked list, doubly linked list, circular linked list. Next topic is doubly linked list, second category of the linked list. Now see, doubly linked list is a variation of linked list in which navigation is possible in both ways. What does it mean is, in the singly linked list, we can move in the forward direction only because we have only one link. Head link to node 1, node 1 to node 2, node 2 to node 3. Only forward link. But here we have two navigation links, two links that is used for the forward and backward easily as compared to the single link list. So for the implementation of the doubly linked list, we use two pointers. next pointer, and previous pointer. So in the previous single linked list, we use only single pointer, but here we have two pointers. We are maintaining two pointers. What is next? Each link of the linked list contain a link to the next link called next. In simple terms, every node contain a link for the next node that is called next link. Previous link, nothing but it is used to move from the one node to its previous node. That is previous. By the name also you can understand that. Link for the next node, link for the previous node. See the graphical representation of the doubly linked list. See head node, and I have a previous link. Observe here, this is one link, and one more back link also. Right? For every node, we have one forward link, backward link, that is previous link, and the next link. Okay, next link, previous link. And obviously, this is the last node. For the last node, there is no next node. That's why it is used to represent a null. So as per the above illustration, following are the important points to be considered. Double linked list contain a link element called first and last. Each link carries the data field and two link fields called next and previous, as we covered. Each link is linked with its next link used next link. Each link is linked with its previous node using the previous link. And the last link carries null because there is no node after the last node. These are the important points about this diagram. Next, what are the operations we can perform on doubly linked list? As usual, what are the operations we can perform on the singly linked list? Probably we can perform all those operations with doubly linked list also. Insertion, deletion. In the insertion also, we can insert the element at the beginning of the list, and we can delete the element at the beginning of the list, or we can insert the element at the ending of the list, and we can delete the element at the ending of the list. Or if you want to insert any particular element after any particular node also, we can do that. So overall, we can implement insert, delete, display, search also. Then, what are the advantages we have in doubly linked list? As each node has pointers pointing to the previous and next nodes, the double linked list can be traversed easily in forward as well as backward direction. So in the single linked list, we have only one direction, just like a one-way road. If you want to come back, you need to go far away and you need to take the U-turn, right? That is what happens in general. But here, this is a two-way directional, bi-directional. At any point of time, if you want to move in the forward direction or in the backward direction, you can do that. No need to traverse until the ending point. Okay. So this is a very good advantage we have with doubly linked list. You can quickly add the new node just by changing the pointers. So if you want to add any new node, you need to change the pointers. Previous pointer, previous node pointer, after node pointers. That's it. Similarly, for the delete operation, since we have previous as well as next pointer, the deletion is also easier. It is very easy to implement the delete operation also. Then what are the disadvantages it has? Since there is an extra pointer in the doubly linked list coming when compared to the singly linked list, that is backward previous pointer. For that also we need to maintain some memory. That's why whenever we consider about the memory, doubly linked list occupy more memory. It requires more memory space compared to the singly linked list. And all the operations like addition, deletion, searching, display require that both previous and next operators, next pointers are manipulated there, imposing the operation overhead. In simple terms, whatever the operation you want to implement in the single linked list, we need to change only single pointer, right? But whatever the operation you want to implement with the double linked list, every time you need to change two pointers. So this is somewhat overhead compared to the single linked list. So these two are the disadvantages with doubly linked list. So third is circular linked list. Before going to the circular linked list, let me show you the code about the doubly linked list. Now see, this is the code about the doubly linked list. As I said already, the major change compared to doubly linked list to singly linked list is here we are maintaining extra pointer, that is previous pointer. Okay. See, this is how to create the node. To creating the node, I define a class with the name node. And what you want to maintain in every node? Three parts. First part is previous, that is a pointer that is used to point the previous node. And the middle one is integer. Okay. Middle one is integer. That is a graphical representation, generally what we use. And the next one is next link pointer that points to the next node. So these are the three parts we want to maintain in the node. That's why I declare those. Now, constructor to initialize the node. To create the node, to initialize the node, we're using one constructor. The constructor name must be same as the class name. We know that that is a rule in Java. And we need to receive the value at the runtime. When we create the object to the class node, we need to pass one value. By that value, by using that value, a node is created. And that value will be assigned to the data. We created already data variable. And at, initially, previous is null and the next is null. Right? At the time of the creation of the null, we didn't have any links. That's why initially every node, previous and next values are set to null. Nothing but that node doesn't have any links. That is not giving any reference to any node. So close the constructor, close the class node. Now, so that is about how to create the node. Now, create the structure of the doubly linked list now. For that, I am using a class, doubly linked list class, and I need to use node, right? For that, I am creating the object to the node class. Okay. Head is the first one, first node. That's why I'm creating head here. And to insert the elements in every node, method to insert a new node at the end. Okay. And we need to receive this data at the time of the calling the insert method. So every time we receive a element, we need to create a new node at the end of the existing linked list. So this is the code we are using to create the new node, creating the object for the node. Already in the node, we defined how to create a node. If head equals to null, if the head value equals to the null, nothing but if it is true, we are going to assign a new node as a head node. Okay. The newly created node is treated as head node because that is the first node. Suppose that is a second node, the head pointer is not equals to null becomes false because the head value has some pointer value of the node one. If any node exists, if no any node is exist, if that is the first node, head value is equals to null obviously. Okay, because that doesn't have any reference that is not pointing to any node as that is the first node itself. There is no node to point. Else, in the second case, and a new node, temporary node is created. And after that, every time we are going to traverse to the last node and link last node to the new node and link new node back to the last node. Nothing but create the node and set the two links, previous link to the previous node, next link to the next node. Then delete method. We are defining this method to delete a node and we need to pass the value of a particular node. So in which node you have that value, that particular node will be deleted with help of this delete method. Okay. We need to pass that value. That value will be stored in the variable key. So we need to search for that value every time until reaching to the last element. We need to compare that value. And that's why we are writing loop here. If that value is equal or that value is found, we are exit from this one by deleting that particular element. Then method to display the list in the forward direction. So we are going to print those elements in the forward direction. Suppose if you want to print the elements in the reverse direction, for that also we are writing one more method with the name display backward. Okay, display backward. We are trying to set if it is empty or not. If that is not empty, we are going to use a loop to reach from last element to the first element. Okay, we need to traverse and we need to print every time. Then we are writing main method in another class. So that class name is doubly linked list demo. We are writing main method in this particular class and creating the object for the doubly linked list class and calling the insert method. At the time of the calling those methods, we are passing the elements 10, 20, 30, 40. So nothing but a doubly linked list is created where in each and every node, we have the elements 10, 20, 30, 40. Now, first, after inserting these elements, I want to print the doubly linked list in the forward direction. Okay. Now, doubly linked list after the insertion, list dot display forward in the forward direction. After printing the doubly linked list in the forward direction, again I want to print the same doubly linked list in the backward direction also. Because we have two links now, uh, previous and next. Next, delete the node. We have developed already one method with the name delete. So we need to pass that key value. In which node we have that value 20, that node will be deleted. So doubly linked list after deleting 20. Just I'm giving the information. I want to print that double linked list after deleting the 20. For the better understanding, we are writing this string doubly linked list after deleting the 20. And after deleting that, I want to print that doubly linked list again in the forward direction and in backward direction. So this is the complete logic what we are implementing here. right? So let me execute this code, then it will be clear to you. Now see, doubly linked list after insertion. So we inserted now 10, 20, 30, 40. So this one, after executing this, in the forward direction, the doubly linked list like this. Okay, 10, 20, 30, 40. And the last one is null. Backward direction, 40, 30, 20, 10. Okay. And a doubly linked list after deleting 20. So after deleting, again, we called display method. So there is no 20 here. And in the backward direction also, 40, 30, 10. Right. So this is about the code doubly linked list implementation. Next. So third category is circular linked list. A circular double linked list. The general name is circular linked list. You can call it as circular double linked list also, where we have double linked, two links. In the circular linked list, we have two links again. Circular doubly linked list. Circular doubly linked list is one of the complex structures. In this list, the last node of the doubly linked list contains the address of the first node. This is very important point. Let me read once again. So in this circular linked list, the last node of the doubly linked list. This is a extension of the doubly linked list, you can say. Otherwise, you can understand like this is another variation of the doubly linked list. So the last node of the doubly linked list contains the address of the first node. Point one. Next, the first node contains the address of the last node. This is the structure of the circular doubly linked list. So hence a circular doubly linked list, there is a cycle and none of the node pointers are set to null. So generally in the singly linked list, doubly linked list, we observe null because the last node points to null because there is no address is attached to the last node. But here the last node address, the last node points to the first node again. That is what creating the circular. Now see with this you can understand it easily. Forget about these things. Okay. Suppose if you forget this area, coming to this is doubly linked list only, this area, right? Completely double linked list. Now, what extra we have here is observe this line, observe this line, just only observe this line. Last node, next pointer is pointing to the first node, point one. Okay. Last node, next pointer is pointing to the first node. And first node, previous link, first node, previous link is pointed to the last node. These are two important points about the circular double linked list. Last node, next pointer points to the head node or first node. Head node, previous pointer points to the last node. In this way, it creates a circular. Okay. So there is no ending point. It is a circular. If we reach last node, we can comes to the first one. We can go from first to last also. For example, so let us say we are in the head node. So next, by using the next node, we are here. By using the next node, we are here. By using the next node, we are here. Again, if you use next node, you are going to the redirect to the head node. Again, next node. Like this, it is in the circular notation. Or in second case, suppose we are at the last node. With help of the previous node, we can come to the this node. Let us say 1, 2, 3, 4 nodes. We are at fourth node. With help of the previous link, we can come to the third node. Again, previous link, second node. Again, previous node, first node. Again, if you use previous link, whenever you have at the first node, that is going to be redirect to the last node. Okay. So these are the two important points about circular doubly linked list. Right? Now, what are the basic operations we can perform on circular doubly linked list? Insert, delete, display. Inserts an element at the start of the list. Delete an element from the start of the list and displays the list. Not only start, actually we can insert or delete at any point. That is the actual advantage of the linked list concept. And display the list also one of the basic operation. Now, where we use these actually, what are the applications of circular doubly linked list? So there are many applications in which data can be more naturally viewed as having a cyclic order with well-defined neighboring relationships, but no fixed beginning or end. There is no fixed positions like this is the starting point, this is the ending point. Always that is in the circular manner. In such applications, we use doubly linked list, circular doubly linked list. Hmm. For example, many multiplayer games are turn-based, with player A taking a turn, then player B, then player C, and so on. Like that, the turn will come from one player to another player in the circular manner. A to B, B to C, and C to A to B, B to C, C to A, and so on like that. So to implement such type of the things, we use doubly linked list in the with circular property, circular doubly linked list. So what are the advantages it has? The circular doubly linked list can be traversed from head to tail or head tail to head very easily. There is no this option in the singly linked list, doubly linked list. When we traverse from head to last node, we need to stop that. When we comes to the head node in the doubly linked list, we need to stop that. But coming to the circular doubly linked list, we can traverse head to tail, again tail to head, again head to tail, and so on, like that. Going from head to tail or a tail to head is efficient and it takes only constant time, that is order of one. We covered already about order of one, order of n, and so on. nothing but constant time. If you want to travel from head to tail directly or tail to head directly, it takes constant time. So that is efficient. It doesn't take more time. It can be used for implementing advanced data structures, including Fibonacci heap. I think you know that you have the basic idea about the Fibonacci sequence. In that, every time the last element will be the first element, and the positions will be exchanged, and a new element is generated by adding previous two elements. So, like that, that is in the circular manner, we are going to change the values. So, in such cases, also we use doubly linked list. Okay, circular doubly linked list. What are the disadvantages it has? As each node needs to make space for the previous pointer, extra memory is required. Every node maintain previous and next, as well as last node maintains one more extra link for the head node. Head node maintains one more extra node to the tail node. That's why more space is required. We need to deal with lots of pointers while performing operations on circular doubly linked list. If pointers are not handled properly, then the implementation may be break. As we covered already, here we are maintaining totally four links, right? Previous, next, and tail to head one link, and head to tail is another link. So we need to maintain all these pointers properly for each and every operation. So that is somewhat complicated. If you are not handling these pointers properly, uh, that might be caused to the break the circular doubly linked list. So this is about linked list concept. Okay. In the next session, we discuss about trees. As of now, we covered linear data structures like stack, queues, linked list. Stack and queue, different type of the queues, list, linked list, different type of the list. And we have seen the implementation of stack, queue, linked list also, right? So in the next session, we will start for the non-linear data structures. Those are trees and graphs. What is tree and what are the different types of the trees we have, how to implement that, and what is node, what is uh, subtree, leaf node. We are going to cover all these terminology in the tree concept. Okay. After that, we discuss graphs also. With that, we can complete probably all the topics of our syllabus. Okay. Right.